What happens when the universe's most extreme objects start colliding? Stars, black holes, even entire dimensions. The results are terrifying, hilarious, and completely mind-melting. Let's dive right in.
You wake up like Kyle here after a sleepless night filled with nightmares. Maybe you shouldn't have watched that video about extreme space objects before bed. You learned about two massive blue giants that are basically merging, powerful magnetars, and massive stars that go hypernova, all vaporizing you and the Earth in seconds. Now, Kyle, no need to worry, it was just a video. And that's not even the scariest thing about extreme space objects anyway. We can also collide them and create horrifying scenarios that will definitely make you never sleep again. Isn't that fun and amazing? But to ease you into it, let's start with the least extreme objects, like a white dwarf and a regular star. And yes, I can see you looking unimpressed over there, Kyle. But when we collide these, we create something that is called a cataclysmic variable. This happens when the white dwarf, which is a dead star core the size of the Earth with a mass around that of the Sun, literally steals the gas away from a regular star thanks to its gravity, and creates a glowing disk around itself called an accretion disk. Now this is where things get extreme. The pressure on this disk gets so intense that the hydrogen is instantly cooked. The disk gets hot, really hot, like 100,000 degrees Celsius hot. Why? Because now the gas is also violently smashing into the white dwarf and boom! The whole thing flashes so ridiculously bright that you can even see it from Earth.
So basically, a white dwarf is the ultimate cosmic roommate thief, just casually siphoning gas from its neighbor like it's stealing Wi-Fi. The result? A cataclysmic variable, which sounds less like astrophysics and more like a metal band. The wild part is the accretion disk gets to about 100,000 degrees, which is hotter than every Hot Wings challenge combined. And when it flashes, it's visible from Earth. So congratulations, Kyle. Your neighbor's stellar drama just turned into our nightlight.
Yeah, Kyle, who's unimpressed now? It's time to level up the extremity even more. Let's now collide two different types of absolute monsters, a neutron star and a massive blue supergiant. A neutron star is smaller than a white dwarf by a lot, but way more dense. It's born from a massive star supernova and made of only degenerate neutrons, whereas the supergiant is a really hot star 30 times more massive than the Sun. When these two collide, the neutron star siphons the massive blue supergiant's gas into a blazing accretion disk. And yes, that's just like our first scenario, but instead of 100,000 degrees hot, it's up to 50 million degrees hot. And this time, it's not just a bright flash, it's a full-on X-ray hellstorm. And all of that happening at over 9,000 times the temperature of the Sun's surface, because all that matter is being flung inward and slammed straight into the neutron star's crust, at nearly the third of the speed of light. The type of system these extreme space objects are in is called a high-mass X-ray binary system. The gravity here? Insane. Like over 100 billion times that of the Earth's to be exact. These things are so bright that they're among the most powerful X-ray sources in the galaxy.
A neutron star and a blue supergiant colliding is basically the worst long-distance relationship ever. One side is a collapsed core the size of a city, the other's a diva 30 suns thick. The result? An accretion disk so hot it hits 50 million degrees, which makes the white dwarf drama look like a candle. And then comes the X-ray hellstorm, blasting space with radiation so intense it outshines entire galaxies. Honestly, Kyle, unimpressed yet? Because this is cosmic gaslighting. Literally.
And the scariest part about this, Kyle, we've seen this happen on the Centaurus X3 system. So in your nightmares, this would be something that still exists when you wake up. But don't worry, we're just getting started. I'll really show you what true horror is, as we keep increasing the amount of energy we get from colliding even more extreme space objects together. Like using, say, the blue supergiant from before and matching it up against a black hole. Obviously, you can't see a black hole, but one of the reasons we can at all? Accretion disks. When a blue supergiant collides with a black hole, the gas of the blue giant forms a blazing accretion disk for it. But now, this isn't just any accretion disk, no. It's like one of those pizza ovens except it opens a gateway to hell, because it has a temperature of 1 billion degrees Celsius.
A blue supergiant versus black hole is basically the space version of don't stick your hand in the blender. The star's gas spirals in, forms an accretion disk, and suddenly you've got a 1 billion degrees pizza oven from hell. At that point, hydrogen isn't just cooked, it's straight up vaporized into plasma soup. And because it's around a black hole, all that light is twisted and warped, turning the universe into a cosmic funhouse mirror. Except, one that screams in X-rays.
But here's the thing. This disk is called Super Eddington, and no, that doesn't mean it's a British gentleman. It means the black hole is eating so fast that the pressure builds up and blasts some of that gas back out into space because it physically cannot eat more. So it's not just sucking, it's spitting too. It does this in the form of two jets that blast out from the poles of the black hole. And this puts out more energy in a second than the sun does in a month while moving at nearly the speed of light, millions of kilometers per hour. And they're not always just stable beams. They can wobble like drunk hobos outside of your window when you're trying to sleep. By the way, the system is also real, Kyle, and is called Cygnus X1, one of the most well-studied black holes in the universe. Oh, what's that? You're trying to act brave because you're so far away and it doesn't bother you? Alright, get in the ship, you little sh**. We're going to get up nice and close. It's about to get absolutely terrifying. First up, we have White Dwarf versus White Dwarf. It might look like they are quite relaxed as they orbit each other, but don't be fooled, Kyle. Once they get too close, one will start leaking some degenerate gas onto the other. Then, as soon as the bigger one crosses 1.4 times the sun's mass, aka the Chandrasekhar limit, the laws of physics will throw a tantrum, and then the white dwarf that was eating everything doesn't collapse and instead detonates in a carbon-fueled special supernova glowing like 5 billion suns. Beautiful. Oh no, I forgot your sunglasses.
I love this guy's style. It's so deceptively simple, but still absolutely wildly entertaining. He'll drop a terrifying astrophysics fact like a billion-degree pizza oven, and then casually compare black hole jets to drunk hobos wobbling outside your window. That mix of high-stakes cosmic horror and dry humor is exactly why it works. You're laughing while also realizing the universe is basically designed to vaporize you. It's science class, but with punchlines.
Well, you can't see anything, but astronomers love these supernovas because they explode with almost the same brightness each time. And so they use them to measure distances of objects across the universe, and that's a fact. Did you enjoy that death, Kyle? I thought that was pretty powerful, but not as powerful as this next one. Neutron star versus white dwarf. As these two spiral together, the neutron star's gravity can rip the dwarf to shreds like it's paper mache. The gas can form into a white hot accretion disk, again, and will start lighting up with high energy flashes. Again, in the chaos you might even get a mini gamma ray burst. It's not as deadly as a big gamma ray burst, but it's still enough to vaporize any nearby planets. And you, Kyle. And now for some neutron on neutron crime. A neutron star versus another neutron star. You've seen collisions, but you haven't quite seen a kilonova like this. Two pulsars, fast rotating neutron stars, spiral inward, losing energy to gravitational waves, which are actual ripples in space-time. Their orbits tighten, time ticks, space trembles, contact. The collision is so powerful it forges the universe's rarest elements in seconds. Gold, platinum, uranium. The flash briefly outshines entire galaxies, and meanwhile the gravitational waves spread across the universe, stretching and squashing space-time, including your ship, your whole body, your bones, your limbs, your DNA.
Neutron stars colliding is like the universe's version of a jewelry heist, except instead of stealing gold, they're literally manufacturing it on the spot. Boom, instant kilonova, forging platinum and uranium like it's some cosmic Etsy shop. And the kicker? The blast is so insane it makes galaxies look dim for a moment while gravitational waves ripple through space, casually stretching your bones like cosmic Laffy Taffy.
I think you get the point. Now that's violent, but not as violent as when you collide a neutron star with a black hole. Wait, what's that? You want me to stop, Kyle? But I thought you wanted to get rid of your nightmares. Have you ever heard of facing your fears? Watch closely as this black hole grabs a neutron star's front and yanks it forward, then the middle, then the back, and in seconds it becomes a glowing spaghetti noodle, torn apart by tidal forces so extreme they'd snap the Earth like a Pringle. This is called spaghettification. And yes, that's the actual term.
Spaghettification has to be the goofiest scientific term ever attached to one of the most horrifying deaths imaginable. Like astrophysicists looked at a neutron star being violently shredded into a cosmic noodle and went, yeah, pasta vibes. It's equal parts cartoonish and nightmare fuel, turning a star into linguine at near light speed. Honestly, it sounds less like physics and more like a rejected Olive Garden promotion. When you're here, your family, unless you're near a black hole.
How else are black hole families gonna have pasta night? But that accretion disk will be eaten in a few milliseconds. When the neutron star gets shredded and the accretion disk forms, before that material crosses the event horizon, it unleashes a short-duration gamma-ray burst, and even more gravitational waves. A flash of light so powerful it outshines the entire galaxy for a few seconds. Yes, more than a kilonova, but basically all the energy the sun will ever produce released in under 2 seconds. That's still longer than a last in the bedroom, Kyle, but that's besides the point. And in fact, speaking of holes, imagine two black holes colliding instead. You don't see them, you feel them. Space ripples as their orbits get closer and closer. They spiral in tighter and faster. But the moment they collide and merge, there's no boom but gravitational waves race across the universe. We can't see it like all the others, but detectors on Earth will. It's the death scream of two collapsed stars merging into one. Nothing escapes, nothing remains, not even you, Kyle. Gravity always wins. But that's what happens if they're just two black holes around the mass of the sun, because they'd only be as wide as like 3 kilometers. So let's zoom out, Kyle, way out, past the sun, past the large stars, and past the galaxies. You see two supermassive black holes, monsters millions or even billion times the mass of our sun. Oh wait, those are the galaxies. They're the engines at the heart of the Milky Way and Andromeda. And yes, they're going to collide. When these titans spiral in, they don't just attract each other. They grab everything else, gas, dust, stars, and they fling them around like bowling pins. Like how your limbs flew around that one time I took you to that exoplanet, except way bigger. And some stars will be thrown out of the resulting galaxy entirely, launched at speeds of over 1,000 kilometers a second into galactic space. Others will be eaten as the black holes feed on this mess, and as their accretion disks ignite, they will glow hotter than 10 million degrees Celsius.
Two supermassive black holes on a collision course isn't just galaxy business as usual. It's the ultimate cosmic bar fight. Every star, gas cloud, and dust mote nearby becomes collateral damage, either hurled across space like bowling pins or swallowed whole.
Jets of hot gas will burst out from their poles at 99.9% the speed of light. And these jets can stretch across hundreds of thousands of light years, carving holes in whatever is still in the way. And then in the final moment, when they do finally merge, the new black hole could reach over 100 million solar masses. The gravitational waves it emits, they'll radiate away more energy than the output of all the stars in the universe in a few seconds. We're talking energy in the range of 10 to the 54 joules, which compared to all the other explosions that you've seen is simply outrageous. The worst part about this, Kyle, in roughly 4 billion years, this fight is most likely going to actually happen, and I'll make sure you're alive to feel it. Congratulations, you made it, Kyle! You experienced every extreme space object colliding that we know of. That's right, things can get way, way worse. It's the final boss battle, a black hole and a white hole colliding. One sucks everything in, the other spits everything out. This is not only a collision, it's a contradiction. See, black holes increase entropy. That's just a fancy way of saying everything gets messier and worse over time. Just like your life right now, Kyle. That's entropy. It's the reason your ice cream melts but never unmelts. Now, a white hole might be theoretical, but it does the opposite. It lowers entropy. It tries to unmess the universe, which in physics terms is just straight up illegal. Black holes drag space-time in like cosmic drains sucking down stars, light, time itself, and once you're inside, you're done. You go in, you don't come out. But a white hole, it pushes space-time out. You try to go in, and the universe tells you, nope, stay out. It's like trying to run a nightclub that's actively throwing people out at light speed. And even if you show it with a bottle service and a fake ID, Kyle, you're not getting in.
Jets ripping out at 99.9% light speed. That's basically the universe's version of a leaf blower, except it clears out entire star systems instead of autumn debris. Then comes the merger, a 100 million solar mass beast, screaming gravitational waves stronger than all the stars in the universe combined. Outrageous doesn't even cover it. And just when you think that's the final boss, physics trolls us with a white hole, the cosmic bouncer that literally refuses entry. A black hole sucks, a white hole spits. It's less astrophysics and more dysfunctional family reunion.
But here is where it actually gets weird. Some physicists think black holes and white holes might actually be the same thing, just viewed from the opposite sides of time. One theory says that every black hole could eventually become a white hole. And after all that collapsing and compressing, boom, it explodes in reverse, like space-time burping out everything it ever ate. You're still with me, Kyle? So what happens when they collide? Exactly, no one knows. Some physicists think it might form a Schrodinger's hole, where it's both a black hole and a white hole until someone looks. Others think it could create a ripple so violent it reverses local time, which would be good for me because I could let you experience all this trauma and death over and over again. But here's the thing, we can still go even crazier than this. Imagine smashing two bulk objects together. Not stars, not even black holes, but entire structures from higher dimensions. In string theory, our universe could be a 3D membrane, or a brain, floating in a higher dimensional space. And these brains, well, they can move, they can collide. And when they do, it's not just a boom, it could be a big bang, literally. Well, theoretically literally. Some big brains think our entire universe began with a brain collision. So if two of them crash again, you don't get an explosion, you get a new universe. Or maybe 1,000, or maybe none. Or maybe the universe you're in merges or ceases to exist. You would start to feel the fabric of space tear around you, then it gets worse. A baby universe starts bubbling inside ours. It's inflating rapidly, trying to grow. The moment it connects with our space-time, the rules change, physics updates without your consent, and if you're lucky, you pop out into a new universe with different rules and probably die. See, Kyle, wasn't that an amazing story and experience? Sleep well. I hope it fixed your nightmares. Wait, you're traumatized and can probably never sleep again? Well, at least be grateful it wasn't as traumatic as Saturn's existence.
So in the end, Kyle just went from sleepless nights to full-blown existential horror campfire stories, black holes slurping, white holes burping, and entire universes colliding like it's a round of cosmic bumper cars. The idea that our whole universe could be the debris from some higher dimensional crash is both insane and oddly poetic, like reality is just somebody else's physics experiment gone slightly wrong. Gravipol really outdid himself with this one. The link's in the description. And trust me, the next video, let's just say things are about to get even stranger than space pasta. Stay nerdy.